This is the 11.5 section on exploring solids. So geometry is now going 3D. Woohoo! So we've studied polygons before and especially spent a lot of time studying triangles and quadrilaterals. And now we're going 3D and we're going to study solids. So like figures that we actually see in real life. And there's lots and lots of solids out there. We've got prisms, we've got pyramids, we've got cylinders, we've got cones, we've got spheres. Here's an octahedron. You've seen a lot of these, like a can of Pepsi kind of looks like a cylinder like this, or you've played basketball with a sphere, or maybe you've been driving on the highway and you've seen some cones, or maybe you've watched TV in the $25,000 pyramid show. So these are things I know that you've seen before. Now, there are two types of solids in geometry. There are polyhedra, and that's plural. A singular one is polyhedron, or non-polyhedra. Non-polyhedra basically have roundy parts. So if your solid has got a roundy part on it, then it is going to be classified as a non-polyhedron. If it has nothing but just straight faces and straight edges and straight lines, that would make it polyhedra. So it's important to realize that polyhedrons are made of polygons, so there's no circles allowed. So if you've got a basketball, like a sphere like that, that is one of the non-polyhedra solids. And if you've got something like a die or a box of crackers, that's most likely a polyhedron, part of the polyhedra family. So let's talk about polyhedra solids. So a polyhedron, by mathematical definition, is a solid bounded by polygons. So every single face on the polygon is a polygon. And we call those faces. And then you have edges of a polyhedron. So this is an edge right here. And then we have pointy parts of the polyhedron, and those are called the vertices. So in this case, this one has several vertices. It's got 4 on the bottom, and it's got 4 on the top. So this particular polyhedron has 8 vertices. And then we can count the faces. There are 4 faces going around it, and then there are 2 side faces. So this has 6 faces. We classify solids by the shape of the base. So if the base or the bottom part of the solid is like a pentagon and it's a prism, we'd call it a pentagonal prism. So this is a pentagonal prism. All of the faces are made up of rectangles, okay? So the bases here would not be a rectangle. These would be the faces. So the base would be the top and the bottom pentagon, and then because it's going around as a prism, it's a prism. This over here is a pyramid. It's pointy at the top. Pyramids are pointy at the top. At least they are over in Egypt last time that I checked. And this one has got a triangle base. So this is a triangular pyramid. So we have 5 very, very special solids. They're called platonic solids. I think you've heard of people have like platonic relationships. Those are really benevolent relationships. We have kind of like a 5 numbers of what you call almost like perfect solids, but we call them platonic solids. And there's only 5 of them. And they have either 4, 6, 8, 12, or 20 faces. So a tetrahedron here is made up of just triangles. This has got 4 faces. A hexahedron, which is like a standard one of 2 dice. You know, if you throw dice, that's usually a hexahedron. That has got 6 faces. An octahedron, octo has 8 in it, like octagon. That has 8 faces, so an octahedron has 8 faces. And then a dodecahedron, again, deca means 10, do means 2, 2 and 10 mean 12. A dodecahedron has 12 faces. And then this one here has 20 faces, and I'm wondering if you know the name of it. To be honest with you, when I first started teaching geometry, because I've learned about isosceles triangles, I call this an icosahedron, but that's actually not the correct way to say it. This is an icosahedron, like cosine. Icosahedron has 20 faces. We can either have concave or convex polyhedra. If I can connect a vertex outside of the figure, then it is going to be concave. Otherwise, it is a convex polyhedron. So if I can take a string around a figure and it matches like the width around it, then it's convex. If I have a gap, if I took a string around a figure, then it would be concave. It caves in, that makes it concave. I would say, honestly, most of the work that we would be doing with solids would be convex. All right, here's Euler's formula. So Euler's formula says this. If I take a convex, okay, it's got to be convex, polyhedron, and I take the number of faces and the number of vertices and add them up together, that's going to equal the number of edges plus 2. So F plus V equals E plus 2. F is faces, V is vertices, E is edges, and 2 is 2. So let's take a look at this. So we've got a figure here. Looks like all the side lengths are the same here, but this could be either a rectangular pyramid, or you could call it a square pyramid, or you could just call it a pyramid. And then when we count the faces, we've got 4 faces around the top, and we've got a face in the bottom, so that's a total of 5 faces. And then I usually do the faces and vertices because Euler's formula is faces plus vertices equals edges plus 2. I find it a lot easier to count faces and vertices and then figure out the edges. So vertices, there's 4 vertices in the bottom and a vertex on the top, so there's 5 vertices. So 5 plus 5 is 10, and then I subtract 2 to find the edges. So there are 8 edges in this pyramid. All right, so here we go. We've got a prism here that's got like a triangle base on the top and bottom. So this is a triangular base, or sorry, triangular prism. All right, counting faces, we've got 1, 2, 3, 4, 5. So there are 5 faces on this triangular prism. And then vertices, there's 3 in the front and there's 3 in the back for a total of 6. And then to figure out edges, I just take 5 plus 6 and subtract 2. So that's 11 minus 2, and that would be 9 edges. All right, so here is our classic hexahedron, or you could call it a prism or a square prism. Faces, we have 4 going around the middle and a top and bottom, so that's 6 faces. Vertices, we have 4 on the top, and we have 4 vertices in the bottom for a total of 8. 6 and 8 is 14, minus 2 is 12, that gives us 12 edges. All right, so that brings us to the end of this presentation. For Thursday's assignment, I want you to go to page 746 and do problems 1 through 10. On pages 746 through 748 on Friday, I want you to do 11 through 20, and then add 32 and 34. Don't send me Thursday's assignment until you're done with Friday's assignment, so you'll send them both together on a new email on Friday. And I hope this presentation was helpful for you. Thank you.